Assalamualaikum and very good morning. I'm Muhammad Al-Amin from Group 11M. I will answer the question for the question 12. The differentiate between Poiseuille flow and Couette flow. For the Poiseuille flow is a flow of fluid which between two fixed plates. It is also considered no velocity at the plate because both plates are at rest. The flow in the Poiseuille flow also caused by the pressure gradient, which means there are pressure difference in a flow. Next, I will pass to my group mate Reda Amiro for explain the Couette flow.
Okay, now for the Couette flow. The Couette flow is a flow of fluid between a moving plate and a fixed plate which is at rest. The moving plate has its own velocity as a result of application of shear stress, which means in this flow there is no pressure gradient in the fluid. Okay, now for combination of Poiseuille flow and Couette flow, I will pass to Joe.
Good morning, my name is Joe. Now let's consider two cases that combine Poiseuille flow and Couette flow. So for the first case, the top plate will move from the left to the right, and there is high pressure on the left and low pressure on the right. So the forces due to the pressure gradients are in the same direction as the top plates, which is from the left to the right. Now we will sketch the velocity profile as follows by no slip condition, and the velocity at the bottom plate must be 0 and the top plate must be V. If the pressure gradient is equal to 0, we will have the Couette flow, which will be a linear velocity profile from one to the other. Because of the high pressure on the left and the low pressure on the right, the velocity profile will tend to bend into a parabolic manner. And now we can make two important points, which is the flow is a parabolic flow and it is a steep velocity gradient at the bottom plates, which means that the dvs per dy is large. Okay. The second case is the top plate still move from the left to the right. However, the pressure gradient push in the opposite direction, which is the low pressure on the left and the high pressure on the right. So we can still sketch the velocity profile as before. Bottom velocity must equal to 0, while the top plate velocity must equal to V. So now we will get a Couette flow with a linear velocity profile. Due to the opposite direction of the pressure gradient, you will get a velocity profile in this shape. We can conclude that this velocity profile is a parabolic. And the other important point is around the bottom plates, the flow can be reversed, which means that dvs per dy is a negative. And one way to think of that is the pressure gradient tends to push the fluid backwards, while the diffusion on top of the top plate tends to push the fluid forwards. So we can say that there is a competition between the pressure gradient pushing backwards and momentum diffusion from the top plates pushing forwards.
Assalamualaikum. My name is Muhammad Shafiq, and I will explain the last sub question for the question number 12. So for the last sub question is the application of the phenomena Poiseuille flow and Couette flow. So we can see this phenomena in the screw extruder. So screw extruder is a machine that has been used to form polymer into the desired shape. So this is a figure of the screw extruder. So for the analysis, we can view from the screw.
Yeah, okay.
When we analyze from the screw, this figure will be like this. And so we assume that the momentum, the velocity in x-axis and y-axis, x-axis and z-axis is equal to 0. So there is only pressure difference in y direction. So when we integrate this equation, we can yield the velocity profile like this. This is a velocity profile. So to find the C1, with the boundary condition that z is equal to 0, y equal to 0. Velocity in y direction is equal to 0. So to find the C2, we use the boundary condition that at z equal to h, the velocity in y direction equal to v cos theta. So then the final equation will become like this. So this equation predict a Poiseuille type backflow caused by the adverse pressure gradient, and the Couette flow, forward flow, caused by the relative motion of the barrel to the screw. So we can describe the velocity profile like this. It will become like this. So we can say that this phenomena we can achieve by the application of the screw extruder. That's all from group 11M. Thank you.